to the fourth series of the EDT seminar. We are very happy to start again a new series, and to our first speaker, Francis. So just a word before I introduce the talk of today. So we have so far two talks in this new series that have been confirmed. So today, Professor Francis Bordeleau will give us a talk. The next one will be given by Shaukat Ali. We still have another one, but still gonna be announced. And as it has become kind of tradition in this EDT seminar, we have panel discussion at the end of each series. And in this one in particular, we will have speakers from this series, but also speakers from the previous one, as at the end we didn't manage to find a date for our previous speakers. So again, hopefully it's gonna be a rich discussion in the next panel. It's gonna be at the end of around end of November. So today we are very honored to have our first speaker, who will be given by Professor Francis Bordeleau. He will open this new series of talks. So he has a master and PhD in computer science from Carleton University. He is the chairholder of the Callum Telus ETS Industry Chair in DevOps at the ETS University in Montreal. He has over more than 24 years of experience in industry with companies worldwide in software engineering, in particular, among which he has worked as a product manager, software development at Ericsson. He was director of tooling business at Prismtech. Prismtech. And he also was the founder of CMind, and founder and CEO of Zelig Soft. So today we are very honored to have you among us, and he will be talking about his ongoing research around a digital twin approach for the systematic improvement of DevOps processes. So Francis, thank you very much again for accepting our invitation, and I guess the floor is yours for the presentation. I will let you share your slides.
Okay, thank you very much for the invitation. It's really great pleasure to share those slides with you guys. In fact, this is work in progress. So let me see if you can you see the slide? Yeah?
Yes, yeah, we can see
the proper view. Okay, so this is work in progress. In fact, it's work that is being done in collaboration with well, essentially three profs: Jürgen Dengel, Sebastian Moza was here, and Mohamed Sayag, professor at ETS with us, mostly working on machine learning, but also in collaboration with two companies, TELUS, who's a service providers, telecom service providers in Canada, like Orange or any of the providers in Europe. It's part of the big three. And Callum, who's essentially a group of ex-Ericsson people who are working on software-defined network infrastructure type of thing. I'm not going to get into the details of this in this presentation. So the reflection here is, okay, we're working on systematic improvement of DevOps processes from many angles in the context of software-defined networks. But again, I'll put that aspect aside for now. And the reflection here is, how can we take this? I'll talk about this work and how can it be extended to more of a digital twin approach. By the way, you can stop me at any time, ask questions, make comments. I see this as an interactive session, so please feel free to do it. So essentially, I just want to go through some of the essential parts of digital twins. One of the aspects I think that plays critical role is this notion of telemetry and monitoring. Not that the digital twin is just telemetry and monitoring, but it plays a key role in it. And then I'd like to move into software processes, because the reflection here is, how can we take this approach and help improving software processes, DevOps in particular, and then reflect on what does it mean to go for digital twin. If we have time, I can give an overview of some of the work that we have done using this type of approach, essentially focus on the code review process that we are currently extending. I'll talk about that. Okay, so first thing, I think no surprise for everybody here, digital twins have been used in a broad range of context. I guess started from physical systems, right? That's why we have so many definitions of digital twins that talk about digital replica of a physical systems. But digital twins are far more than just for physical systems now. I think that examples, and here is just essentially, I use the pictures that I could find interesting, but also related to interesting papers. In the medical domain, I think that when we go into experimental treatments, if we go into the introduction of new drugs, we have cases like the one that is presented here for MS, that where we want to use potentially a digital twin to follow the evolution and the reaction of different patients with respect to a given treatment, or even, I think in this context, it's quite interesting to look at the community of twins to try to learn from each other, right? If I give one patient with a given profile a certain drug, and I have someone else that has a similar profile, then how can I, use the knowledge that I can extract from one usage to treat another patient, for example? The one of the greenhouse, right? Whether I want to grow tomatoes or I want to grow strawberries or whatever. In this case, what's interesting is that I may have, and I'm talking to people who are working in this domain, and there's essentially two twins. There's a twin of the greenhouse itself, where it's essentially an HVAC specific utilization of a HVAC system to control the greenhouse, maybe optimize energy consumption, whatever. And then I can have a digital twin of the plant itself. It's two different natures, right? One is an engineered system, the other one is a natural system. And I can go beyond that, and I can have a digital twin of a smart city. And then in this cases, sorry about that. I'll rectify the reference here is clearly not the multiple sclerosis example. So I'll change that before sending, but I have the digital twin example of the smart city, where you can have different layers or different aspects of the system. And in these three type of non-physical systems, or actually not reduced to physical systems, what's interesting is that, of course, I have many dimensions. And I think that there's some of it that we can reuse in the context of software processes. So ultimately, what are digital twins used for? We had quite long discussions in Dash tool about this. Yes, it could be simulation. Yes, it can be monitoring. Yes, it can be diagnosis, prediction, optimization. But essentially, what I want is to be able to do things with my digital twin that I could not do with the actual system or physical systems in some cases, right? So that's the basis, or those are the things that I would like to use as a basis here. Now, telemetry and monitoring play a key role in this. So if we go to the definitions, and of course I could have thrown out like many definitions of telemetry, but one in Wikipedia say that it's the in situ collection of measurements or other data at remote points and their automatic transmission to receiving equipments for monitoring, or the science and technology of automatic measurement and transmission of data by wire, radio, or other means from remote sources, as from space vehicles to receiving stations or recording of analysis, and so on and so forth. My son is actually researcher in marine biology, and yes, they use telemetry all the time. He was in Denmark last week to go tag seals and to go tag fish, and in fact they want to get those data and try to do the analysis. If we look at some definitions in the industry now, this is the picture that Azure is giving with respect to digital twins. In fact, what we see here is collection of data that are routed to the cloud. So is it a digital twin? Yeah, maybe it's a basis for digital twin, but I would say this is a telemetry infrastructure more or less, right? But that shows that telemetry plays a key role here. But telemetry and data are not sufficient. In a paper that we wrote in collaboration with Mark and other people here, Benoit, and we need models as well, right? We need models to extract information from the collected data, interpret the data, right? I mean, once we have data, the good thing, I mean, with data science now, we can do a bunch of things. In the context of digital twin, we need different type of models, whether they are structural, behavioral, data analytics, that we need for different purposes, for analysis, simulation, diagnosis, monitoring, data analytics, and so on and so forth. And the models we choose will depend on the purpose of the twin that we want to develop, right? So that's somehow the reflection we're in is, okay, from if I want to go to DevOps or to software or DevOps process evolution, what is it that I will need to use? Software improvement is by no means a new topic, right? There has been, since essentially the coining of the term software engineering in 68, has always been a constant focus. How can we improve software processes? Right? There has been so many, I mean, essentially all of the research we do somehow is geared towards that. And several initiatives like ISO, CMM or CMMI, SPICE, Trillium, essentially the kind of the first generation of these process improvement methods were based on process assessment. To me, that's okay, that's good because that's what we had. But on the other hand, it's very difficult to be accurate. If we look at how we're improving, evolving system these days, is by using actual data, not try to work on assessment. A work that is quite relevant is the work that has been done on process mining. Right? Initially, process mining was to try to extract the process, the real process, not from someone who had designed it on the board, but to extract it from information that is captured in the process, like files and different type of artifacts. Now, this also has evolved into the use of data to try to optimize the system. So in many ways, that's close to what we're trying to do in the context of DevOps process improvement, but the perspective here is a bit different. So the goal of process mining is to turn event data into insights and actions. You'll see that we're trying to use a slightly different approach, but this is certainly related and close to in the spirit of what we're trying to do. A piece of work that is quite important in the context is, I think, this framework that Turnbull developed or defined around monitoring for software systems. Essentially, logging data, tracing and debug, all of these things are not new at all. At the operating system level, we have different specialized tools to do tracing and debug. At the application level, we've quite used to use logs to log different type of events. But I guess the novelty here, or the focus that this is taking, is that we need to be able, if we want to do monitoring at a higher level in the context of DevOps or others, we need to be able to go and gather information or data, not information, data at the different layers of the system, using the specialized tools that they are using at the different levels, and bring this information to a central repository that can be used for analysis. Because when we do, for example, tracing and debug at the Linux kernel level, the footprint of the information that we're capturing is quite important. So we need to reduce the footprint. So the information tends to be very cryptic. And people that are used to this format will be able to read it and to analyze it. But someone in the business at the business level, of course, would not be able to do that. The logs that are put in by the application developers or the software developers are meaningful for the software developers, and they use different formats and techniques to do that. But they will not mean anything to someone who's working again at the business level or at another level. And for a long time, the problem of system debugging or diagnosis was actually related to this. Is that I remember at Ericsson, we used to say that if we want to debug a system and we were using model-based techniques to generate code, you would need to bring into a room a person that has been developing the software using the modeling technique, UMLRT in this case, and someone from the infrastructure who had the trace and debug, lug them in the room and don't open the door until they have been able to talk to each other and figure out what the problem is, right? So essentially you have different languages, different cultures here that come into play. And the idea of Turnbull was to say, we need to bring this into some type of repository in a format that allows for the analysis by different type of people and the extraction of information. Because in many cases, if we want to do monitoring, we need to be able to combine information that comes from different layers, right? So keep it in mind, because I think that that will be quite central in what we're trying to do here. And then there's just example of dashboard, but again, the only idea here was to be able to represent that there's some generic stuff, but also here's an example at the bottom here about things that are going on at the infrastructure, at the ops level. And here we have metrics that are at the business level, like how many users, where are my users, things like that. So what about DevOps process improvement now? When we started to work with our industrial partners, Calum and TELUS, a thing that is clear is companies are implementing DevOps, right? DevOps can mean everything and nothing. It's way more than tools. But the idea is, yes, people would put in a CI/CD or some type of CI/CD pipelines to automate part of the process. They would use automated testing to do part of the automation of the different stages of testing. But in most cases, it's done in an ad hoc way. You would, for example, introduce a new tool to improve your process. But what tells you that you have improved your process? You may use a different technology for the build process, for the pipelines, but how do you know that things have gotten better? And that's a problem, right? Because essentially what aims at being agility too often means improvisation. And when you do changes in your process, whether it's to introduce a new tool, a new technique, or replace an existing tool by a new one, it's very difficult to measure. Here I said it's partly true in domains like software-defined networks and IoT. I've heard people saying that, DevOps doesn't work in IoT. I mean, that's not true. DevOps works in IoT, but works differently. DevOps is not a fixed thing. It's this idea that we want to constantly improve our process through tools in automation, right? We want to automate as much as possible. So we have this quote that we got when we launched the research chair from Nazim, who's a VP, is now a senior VP at TELUS. that was actually pointing the fact that in the context, just the context of the pandemic, I mean, companies need to be more and more agile to be able to deploy software more quickly. I mean, we have an example here with Zoom, right? If Zoom at the beginning of the pandemic, I mean, that was very interesting because I do remember we had those Friday calls on digital twins, and in North America, we were about 2 or 3 weeks beyond you guys in Europe. And I remember that day on March 11, when you know we had this call in the morning, and everybody, Mark and Manuel, started to say that we're moving to remote teaching. I said, "What are you guys using?" And they said Zoom. I'm not even sure I knew what Zoom was at the time, and of course we learned quickly. But Zoom had issues, security issues at the beginning. If Zoom had only being able to say, "Oh, don't worry, we'll come back in 4 months or 6 months with a new version that will solve all these problems of security," then of course we wouldn't be using Zoom today, right? So the fact that they could do constant deployment, they could deploy many times a day, and they could have telemetry and their application, and they could have quick turnaround to deploy new versions of the solution or new services or updated services. It's what has allowed them to be successful. So the point that Nazim was making here is that as telecom service providers, that's pretty crucial, how fast you can turn around. Is that the use of DevOps becomes unavoidable, but the implementation and evolution of DevOps processes represent a significant challenge for companies. And essentially, that was one of the 2 key elements that started the research chair. Here's a typical example of a software delivery process or DevOps process at Kaloom, like very conventional, right? I mean, this could apply to most companies that I know of that have a certain level of maturity. So you have a coding phase. So this is the software engineering manual or human-based phase. Then you have a first pipeline that will take this code and do unit tests and static code analysis using things like SonarQube. And then we'll do component tests. Here you can see the 2 branches, because if you're working with developing software that are closer to the platform, to the actual equipment, you would need to do the component test on hardware. Well, if you work at the service level or the management level, system management level, you would do it just based on software. And then you have the review phase, which is also the second manual phase, right? And I think will always remain. This as much as we can automate, we will push towards the left side here on the DevOps pipeline. We could add more tools. There are a lot of quite sophisticated tools there to do security assessment and vulnerabilities and stuff like that. But there will always remain a part that will be the peer review phase. And then once you accept the merge request or the pull request, and then you merge the master, then you will launch the build pipeline, the product build pipeline, packaging. And then you could have different pipelines for the different levels or stages of test. In this case, the QL that you can see are the quality levels, and they go from just being able to package to be able to run the 1 hour test to the 24-hour test to the 1 week test, like different level of testing. Some testing goes on in parallel, so the details here are not shown. But essentially, this is quite a typical process. What is the difference about DevOps processes if we compare to software processes traditionally? It's really the tooling, right? So I mean, when I remember having discussions in the software engineering department, even about those numbers that DevOps promote, be able to deploy 1,000 times faster, for example, right? It's yeah, we've heard these numbers before, right? It's just like inflating the bubble. And when you look at it, this is not the case at all, because there's no magic in it. The only thing, or one of the only thing that DevOps has done is actually to automate. Whatever was done manually, then we're looking if we can have tools to automate it. And if we have tools to automate it, it means that we can launch the stages one after the other. We don't have to send an email to someone or open a ticket somewhere and say, "Can you please do that?" Right? Can you please send an email to ops and say, can you please deploy it, or open a ticket and say, I need to deploy this? Of course, we can all automate it. So the tools here are playing a key role in the automation, in the reducing the time, in increasing the quality of the resulting software. But from a process improvement point of view, what this is also giving us, tools provide APIs, and from the APIs, I can get certain data. And while we had to do process improvement, say 20 years ago, based on assessment, then maybe I can now go in a non-intrusive manner, like we do in telemetry. We can have process telemetry. And then I can go and get data. And from these data, I can try to extract some metrics. So some things exist, right? We're not going to reinvent the wheel here. One of the things that we have done so far is that, as I said before, we focused, and I'll talk about that a bit later, we focused on the review stage, the peer review stage in the project with 2 master students. I'll talk about that. And for that, we could go and fetch data in GitLab. So the 2 partners in this case are using GitLab, and GitLab keeps, of course, all of the data about the different projects. And so we could go and fetch all of the data of the merge requests for the last 2 years. We could have gone to 3 years, we could have gone to, but essentially the data are there, they are recorded. One of the things that we're facing is that we need to have pipeline data. I'll talk about that a bit later. And right now, if you look at the way Jenkins is doing it, so Jenkins can show you the data of the different stages of every run, but essentially it only keeps, from a persistent point of view, it only keeps the last, whatever, 10, 100, a certain number of runs, because the quantity of information is quite important. And so when you can visualize the current runs and see how long it takes, but you don't have the historical data so that you can go and do analysis. And that's one of the things that we'll try to do. That's one of the things we're doing now, is to extract this information. I'll talk about that after. But other tools exist, and they can give you different perspective. We believe it's not sufficient. We really need to have a real telemetry, like what Turnbull had put in, some type of repository with data, and then over time we can evolve the metrics that we're going to be using. What about the models? Well, in this case, 2 models that are used for there are others as well, but 2 of the models that are used for DevOps process modeling include BPMN, right, that has been used for business process modeling in general, and value stream maps, which are that are quite used in DevOps, but in many cases they are used quite informally based on assessments. So we would look at the sequence of phases, and then we would could add some information about the tools that are used for the different phases, and then to try to get some data about the lead time, about the process time, about the quality, like complete and accurate and stuff like that. So these are models that are used. We want to see how we can use these models, because even if we go and get data about from the different tools, the process is a good example. So Jenkins is actually giving me the information in this way here, like the different phases. But what I don't see here is if some phases are done in parallel, concurrently, or if they're all done sequentially, because of course this type of dashboard or UIs only give me the sequence with the different measurements of those stages. So in order to be able to calculate metrics, I need not only the data, but I also need a model of the process, without which I cannot calculate all of my metrics. So taking this as a basis, what does it mean, or what can we do regarding systematic improvement using some type of digital twin approach? So first, if DevOps is about continuous improvement through automation, we need to provide support for the systematic. I hate the term scientific. I think that it's overused and abused. But let's put it aside. It will be another discussion. Improvement of the process. The real questions are, what do we need to measure and monitor in a DevOps process? Well, it depends. What are the main flows, using DevOps terminology, that we should or must focus on? And this really depends. We're talking to our two partners in this case. We had a discussion even on that 2 weeks ago. And in the case of TELUS, who's a service provider, their main priority and their main focus is on delivering new services or fixes to problems as quickly as possible. So time is of the essence here. Of course, not at the expense of quality. Quality has to be good, but they want to be able to deliver faster. In the concept of Kaloom, and I won't go into all of the details here, but Kaloom is essentially providing software infrastructure for software-defined networks. So, in fact, they are provider to companies like Kaloom. They are providers to companies like TELUS or Orange or those companies are their targeted customers, so that they can allow them to deliver faster. But Kaloom is essentially releasing a new version of their software every 3 months. Right? So internally they have continuous integration, continuous deployment, but the release is only done to customers every 3 months, unless something urgent is happening. So in their case, quality is the most important criteria, because they need to make sure when they release every 3 months that the quality is there. Otherwise, they will need to provide fixes, right? So time is important. It's very important. They're trying to use the build time. They're trying to maximize the number of tests they're doing within a certain period of time. But ultimately, quality is the key thing in their case. Okay, so just to highlight the fact here that, and this may change over time, right? You may focus here on improving your build pipeline and reduce the time for the build. And once this is fixed, then you're going to move into something else. Then what metrics should we use? Well, depending on my overall goals, my metrics will change. I need to have this flexibility to compute different metrics based on my high-level objective. Once I figure out what I want to measure, the next question is, where do I get the data to compute this metric? And this is where the Turnbull monitoring framework makes sense, because in a way, I need to collect data from different tools. Each of these tools will have its own API and will provide certain data. And then from a data scientist almost, I need to be able to look at this sea of data and decide what I want to do, which metric I can get. And in order to do that, to extract the information or to extract the metrics from the data, I need models. So which type of model do I need? And it will, again, depend on the aspect. Okay, so that's really the context we're in collaboration with Kaloom and TELUS, but also from a researcher point of view with Jürgen, Sebastian is here, and Mohammed. So those are the reflections that we have to go through. And now, concretely, in terms of some of the research projects, well, one of the first things we'll need a framework for capturing the process. So this is the modeling aspect. We have one student, Karen Pulgar, who's currently working on extracting pipeline information from the pipeline, or pipeline models from the pipeline description, whether it's in Jenkins, whether it's in GitHub or GitLab CI. How can we extract the model? Because we want to start from the source. So in a way, it's some type of reverse engineering. And then we need to think of what aspect do we need to have in our models. It's not only that I need to have the sequence of the phases or the steps that compose my process, but depending on what I want to do, I will certainly want to know which tools are used in each of these processes. Are there some scripts that are used to make the transition? What type of pipelines are used? What type of descriptions are used for the pipeline? One thing that I'd like to be able to do at the modeling framework level or the capturing level is to be able to answer change impact analysis questions. What if I want to introduce this new tool in my process? What impact will it have on my different scripts, on my phases, on my whatever, right? So that's one question that I want to be able to answer. Then the measurement aspect. I talked already quite much about this. We want to focus both on time aspects and quality aspects, like the number of defects that are found. I could, for example, be interested in looking at the impact of increasing the time or the effort or the focus we put on the review process. So what if I put more emphasis on review? I asked 2 people at least to review each new commit as opposed to 1. Will it have some impact, positive impact on the time or the quality of the resulting software delivered to the customer, right? This is just one example. Anyway, I can give more later. Okay, so on that aspect, we're going to have, 2 students, 2 PhD students who are working on it now, Sama Kansab and Henri Aidasso. In fact, Henri did his master's in Rennes. So he just joined us in September. Overall, some of the questions is what type of digital twin architecture and platform do we need for the development of digital twins? Okay, that allows, I'd like to implement somehow the monitoring framework of Turnbull to be able to have this type of representation, to be able to gather the data. From a monitoring point of view, I'd like to have some type of alerting that will come when, right? There are 2 phases. So the first phase is to do manual understanding analysis of the data with respect to the metrics. So for example, if I aim at reducing my time for the build time, I will need to go through and understand everything that contributes to the build time. I can use machine learning to try to find some correlation of different aspects that contribute to an increase in the build time or the packaging time. Once I've done this analysis, I could put some threshold on some properties and to be alerted if I see that behavior of the people involved in the process are starting to deviate, or some of the tools are starting to send me wrong data or data that I should be informed about. So the digital twin there, as opposed to just to a dashboarding, can do this automation of monitoring and informing me when things are going in the wrong direction. From the diagnosis as well, because currently, as an example, Kaloom 2 years ago, last year, when moved to OpenShift, which many companies are doing today. And in this case, the time of the build time of their build pipeline essentially went from about 11 minutes to about 21 minutes. And they could, when looking at the dashboard or the Jenkins UI they could see the numbers increasing, but this was, they could not capture it and capture all of the data to do historical analysis after, to see, okay, where is it exactly that things started, when is it that things started to go wrong, and where is it that we had the most significant increase in the stages. So I need this information to be able to run diagnosis. And there, I think the digital twin, not only the data, but to think of digital twin techniques to help with the diagnosis aspect can be quite interesting and important, but we're not there yet. And of course, things like simulation and analysis. Like once we have the data and we have the models, could we start doing what if scenarios? I think there, the digital twin approach can be very useful for software process improvement. So just a quick overview of work done. We focused on, I will just do snapshots here, but essentially we focus on the code review phase. So in collaboration with two students, Syed Benham Mashari and Julien Legault. Julien has just submitted his thesis, and Benham submitted his thesis back in April, March, April, in collaboration with Mohamed Sayag. So essentially we extracted MR data of the last 2 years, essentially a bit more than a year and a half, I should say, 2020 and about 2/3 of 2021. It's just for the data used for the thesis. What's very interesting at Kaloum is that we have there's four layers typically in a telecom system. So it goes from the platform. In fact, the order here should be changed. It goes from the platform to the data plane. Data plane is where all of the bits handling is being done. This need to be extremely performant. So it has specialized hardware and specialized programming languages. Then the management, the control plane and the management plane are more typical software engineering. So using Golang. At the data plane level, they're using a language called P4. At the platform level, it's low-level code. What's interesting here also is that the profile and the culture of the engineers at the different level is quite different. Okay, so when interpreting the data, it was very important to keep it in mind, and that showed actually that process data cannot be, I think, analyzed in the abstract. You need to discuss with the teams. For that, we had, yes, GitLab already provides some APIs, so give you, the time when a merge request is opened, the time when the merge request is closed, size, like the size of a commit is not something that is easy to determine, but gives you some information. But in order to do the work that we aim at doing, we needed to build a tool that was actually be able to extract or to compute some specific metrics that GitLab was not providing to us firsthand. And then we looked at the two students' work at two different aspects. One, Benham looked at trying to understand the behavior of the developers over the 21 days of a sprint. Right? The Kaloum works on sprints of 3 weeks. And so we wanted to know, one of the question management was interested in is there a Friday afternoon effect where people are actually closing more merge requests, right? Weekend is coming. I want to review. I want to get rid of a bunch of things. Let's actually merge. And if that exists on Friday, is this amplified at the end of the sprint? Because, okay, if we don't make it this Friday, then it will only go at the end of next sprint, which is in 3 weeks. And we could extrapolate on that. If you go to the release after 3 months, the things that are not making it in this release will actually only go to the next release in 3 months. So do we have this Friday afternoon effect? It's one of the interesting questions. And then looking at the behavior of the engineers over the 3 weeks, and I'll get to exception and interpretation. But essentially, we looked at things like, okay, what is the average lead time? What is the average size of a merge request in the different groups? Okay, I won't go in details here, but it was providing information that management didn't have. And here's the one here that is interesting that I'd just like to point on is that each of the dots here are representing one merge request. And so this is for the control plane group. It doesn't matter, I'll show you the other groups after. But what can we, so each point here represents one merge request. The size of the bubble represents the size of the merge request. And the y-axis is the lead time. So the time between the time where a merge request is open and the merge request is closed. One thing we read in the literature quite often is that there's a direct relationship, in fact, quite often qualified as exponential, between the size of a merge request or a change of modification size and the time it takes for review, right? So clear, and this has been published in many contexts. Clearly here we see that this relationship is certainly not true here. We have quite large merge requests that takes essentially 0 time or very little time. And we have small merge requests that take a long time. And in fact, this is true for essentially all groups, the 4 groups at Kaloum. Another thing that we observe is that there's not much work being done on days 6, 7, 13, 14, 20, 21. Well, those are the weekends, right? So that's kind of expected. But if we go back to the size, this really brought us to wonder, like, why is it? Is it rubber stamping? Is it just that those large merge requests that are just accepted is a reflection of the fact that nobody really cares, right? They just go in rubber stamp. Yeah, merge request is there. I know the person who did the code modification, accepted. And we realized that it's not really the case. One of the things that was important, I'm just going to move to this exception slide here. I won't go into details of the rest, but it's essentially that the merge request mechanism is not only used for code reviews. It's used for a number of other things. In Kaloum, they have a central group that is doing, for example, code, that is taking care of the pipeline and some of the libraries and so on and so forth. So in several cases, they could decide, for example, to update a library and then they push it to all of the groups. So it has been tested. So in this case, the merge request mechanism is used, but it doesn't require a code review. It's kind of a handshaking mechanism. Here's it, like a library update has been modified. You can use it, and then the people accept to use it. In other cases, it could be some type of different activities, different type of actions, like a rollback that can be done. So the merge request mechanism is used for many other things than just code modification that aims at code review. So the conclusion here is that if we were trying to analyze this without being able to talk to the teams and understand, so the manual look at some of the manual analysis of some of the merge requests, we would get to wrong conclusions. So if we were just going to open source repos and actually try to extract information, we would get it wrong. Okay, so I'll just move to the conclusions and the summary. So in the next steps, so far we've worked on data extraction for merge requests. We're now focused on the pipeline information. We need to extract information about the pipeline, every pipeline job that we can collect and use for future analysis. We have 2 MN students that are working on that. We have Corinne, who's working on extracting the models of the pipeline and be able to look at the evolution of the pipeline against improvement objectives. And we have a person, Mario, who's working on looking at different techniques that can be used to visualize those pipelines. and then the 2 PhD students who will start doing collecting real metrics against corporate objectives, to be able to now feed into more of a eventually a digital twin approach, but to help improving the process. So far we've learned a lot in the last 3 years by working with industrial partners on their needs, on their issues, and on the techniques and technologies they're using. Quite confident at this point that the digital twin approach can be used to automate systematic monitoring and evolution of industrial DevOps processes based on current techniques. And that's one of the goal of the chair, is that we are working in the spirit of open research and really looking for collaboration and exchanging with different people who would want to work on the same type of problems. Thank you.
Thanks, Francis, for this talk. Thank you very much. A really interesting talk.